What is Jetpack Compose? Jetpack Compose is Android's modern toolkit for building native UI. It simplifies and accelerates UI development on Android. Quickly bring your app to life with less code, powerful tools, and intuitive Kotlin APIs. Less code. Writing less code affects all stages of development. As an author, you get focused on the problems at hand, with less to test and debug, with less chances of bugs. As a reviewer or maintainer, you have less code to read, understand, review, and maintain. Compose allows you to do more with less code compared to using the Android view system. Buttons, lists, or animation, whatever you need to build, now there's less code to write. Intuitive. Compose uses a declarative API, which means that all you need to do is describe your UI. Compose takes care of the rest. Now you can achieve so much with a single Kotlin file that otherwise would have extended across multiple XML files. With Compose, you build small, stateless components that are not tied to a specific activity or fragment. That makes them easy to reuse and test. Accelerate development. Compose is compatible with all your existing code. You can call Compose code from your views and views from Compose. Most common libraries like navigation, ViewModel, and Kotlin coroutines work with Compose, so you can start adopting when and where you want. Using a full Android support with features like preview, you get to iterate and ship your code faster. Powerful. Compose enables you to create beautiful apps with direct access to Android platform APIs and built-in support for material design, dark theme, animations, and more. There are fewer steps between the thing you want to make and actually making it. Jetpack Compose is a promising and powerful UI toolkit that you definitely should learn. If used correctly, it can speed up the development process and reduce your app size. Moreover, with Compose you write less code, which potentially means less bugs. Happy learning! Hello, in this lecture I will show you how to download Android Studio. First, open a browser and type developer.android.com/studio. You see the Android Studio official page. If you have Windows 64-bit, you can click here. Otherwise, if you have some other configuration, you can click Download Options and select your platform. After it has downloaded, you should run the Android Studio setup. First, click Next, then select Android Studio and Android Virtual Device. I will use the default path for Android Studio, then click Next and click Install. After it's been installed, click Finish. When it is ready, you'll see the Android Studio setup wizard. Click Next and then select Standard Installation. That is good for most of the users. And you're done, and click Install. Your Android Studio is downloaded. Hello, in this lecture we will create our first Jetpack Compose project. When you open Android Studio, you will be greeted with this window. We should click New Project. After this, we select Empty Compose Activity. Then click Next. We select our name to be whatever you want. My first Compose project. We select our package name, whatever you want. It could become .example.compose project, and then we click Finish. We wait for our project to build, and we see this screen. This is our main activity.kt file. Alright, now our project has been built. This is our main activity.kt file. As I said, here we can see our resources like drawables, and here we will write our compose code. Let's run it and see if it works. If you have an existing emulator, you click display button. Otherwise, you click this arrow and go to AVD manager. Then click create virtual device. Select whatever device you want. Select the API level. Click next and then click finish. But I have an existing emulator, so I'll just click and run it. Alright, as we can see, the emulator has launched inside Android Studio, and we see our first Compose project that says Hello Android. Great, good job. Just to check whether everything is working properly, we can change this string Android to whatever you want. I'll just change it to Hello World. There is no need to understand this for now. I'll explain you later. I will just rerun it. And you see, it has changed. Good job. See you in the next lecture. Welcome back. In this lecture, we will discuss composable functions. First, we will display a hello world text by adding a text element inside our onCreate method. We do this by defining a content block and then calling a text function with the string hello world. The set content block defines the activities layout where we call composable functions. Composable functions can only be called from other composable functions. Jetpack Compose is built around composable functions. These functions let you define your app's UI programmatically by describing how it should look. To create a composable function, just add the @composable annotation to the function name. Let's create our first composable function. We click outside the main activity, and first we will create a simple function name card that will accept one parameter called name, which is a string. Open curly braces. For now, this function is not composable, so we should annotate it with @composable. Alternatively, if you don't want to follow all those steps, you can just type comp and press enter and just type the name. Now, inside our name card, we will add another text with the text of hello $name. Great. Now, if you want to see how our composable function looks like, we can test it and put it inside the set content. We can remove this hello world and type name card with, for example, the name John. Let's run and see it. You see, it says hello John. If you want to change the name, for example, to Donald, you see that it changes automatically. Another way of checking our composable function is to write a composable preview. So we create a regular composable function called nameCard preview, and we annotate it with a preview annotation. Inside it, we add my first composable project theme. This name here will change depending on your project name. My project is my first post project, so this is why it's called like this. If we have another name, it will be called your way. Inside it, we call our name card composable with the name of Sarah, and we can click the split view and wait for our composable to load. To update the previews at any time, click the refresh button at the top of the preview window. As you can see, here is our composable preview with the text "Hello Sarah." Thank you for watching. Hello. In this lecture, we will discuss compose terminology. Historically, an Android view hierarchy has been representable as a tree of UI widgets. As the state of the app changes, because of things like user interactions, the UI hierarchy needs to be updated to display the current data. The most common way of updating the UI is to walk the tree using functions like find view by ID and change nodes, for example, with button.setText or image.setImageBitmap. Manipulating views that way manually increases the likelihood of errors. Over the last several years, the entire industry has started shifting to a declarative UI model. It generates the entire screen from scratch and applies only the necessary changes. This technique works by conceptually regenerating the entire screen from scratch, then applying only the necessary changes. This approach avoids the complexity of manually updating a stateful view hierarchy. Compose is a declarative UI framework. One challenge with regenerating the entire screen is that it is potentially expensive in terms of time, computing power, and battery usage. A simple composable function. Using Compose, you can build your user interface by defining a set of composable functions that take in data and emit UI elements. A simple example is a greeting widget, which takes in a string and emits a text widget which displays a greeting message. A few noteworthy things about this function. The function is annotated with the @composable annotation. All composable functions must have this annotation. This annotation informs the composable compiler that this function is intended to be converted to convert data into UI. The function takes in data. Composable functions can accept parameters, which allow the app logic to describe the UI. In this case, our widget accepts a string, so it can greet the user by name. The function displays text in the UI. It does so by calling the text composable function, which actually creates the text UI element. Composable functions emit UI hierarchy by calling other composable function. The function doesn't return anything. Composable functions that emit UI don't need to return anything because they describe the desired screen state instead of constructing the UI widgets. Dynamic content. Because composable functions are written in Kotlin instead of XML, they can be as dynamic as any other Kotlin code. For example, suppose you want to build a UI that greets a list of users. This function takes in a list of names and generates a greeting for each user. Composable functions can be quite sophisticated. You can use if statements to decide if you want to show a particular UI element. You can use loops. You can call helper functions. You have the full flexibility of the underlying language. This power and flexibility is one of the key advantages of Jetpack Compose. Recomposition. In an imperative UI model, to change a widget, you call a setter on the widget to change its internal state. In Compose, you call the composable function again with new data. Doing so causes the function to be recomposed. The widgets emitted by the function are redrawn, if necessary, with new data. The Compose framework can intelligently recompose only the components that change. For example, consider this composable function which displays a button. Every time the button is clicked, the caller updates the value of clicks. Compose calls the lambda with the text function again to show the new value. This process is called recomposition. Other functions that don't depend on the value are not recomposed. Composable functions might run quite frequently. In some cases, a composable function might run for every frame of a UI animation. If the function performs extensive operations like reading from a device storage, the function can leak to UI junk. For example, if your widget tried to read device settings, it could potentially read those settings hundreds of times a second, with disastrous effects on your app's performance. If your composable functions needs data, it should define parameters for the data. You can then move expensive work to another thread outside composition. Thanks for watching. Hello. In this lecture, we will discuss Jetpack Compose layouts. UI elements are hierarchical, with elements contained in other elements. In Compose, you build a UI hierarchy by calling composable functions from other composable functions. First, we will create a data class that will store the information about a profile, name which is a string, and also a description which is also a string. Let's start by making our profile composable. It will take a profile. It will take a profile as a parameter. Inside the profile card, we'll add two text composables. The first one will have the value of profile.name, and the other one will have the value of profile.description. Let's create a preview composable. We should not forget to annotate to it at preview. Use our theme. This name will depend on your project name. And we add a profile card with a value of profile. For example, John with description. Hello, I am learning Android. Now we click split to see our composable. But look what happens. Those two texts overlap. This is not what we want. In this case, we will use a column. The column function lets us arrange elements vertically. Add column inside the profile card. Add those texts, cut them, and paste them inside the column. If we refresh our preview, we will see when we refresh, we'll see that the two texts are one behind another. You can use a row to arrange items horizontally and a box to stack them. Now we want to add an image element, so we need to minimize Android Studio, get our picture, copy it, Ctrl C, then open again Android Studio and paste it inside the drawable. Here we have our picture. You can use whatever picture you want. So now we can use a row here, and inside the row we add an image that so in order to set this drawable to our image, we use a painter resource with the ID of our profile picture, r.drawable.profile picture. Press Ctrl Alt plus L to rearrange your code, and we add a description of profile picture. We add our column inside the row. Now click again split view and refresh our preview. Now you see that there is a profile picture along with the text. It's time to configure our layout. Our profile layout has the right structure, but its elements aren't well spaced and the image is too big. To decorate and configure our composable, Compose uses modifiers. They allow you to change the composable size, layout appearance, and other high-level interactions, such as making an element clickable. You can change them to create richer composables. Let's use some of them to improve our layout. We use composable by adding a parameter to the functions. Writing modifier, for example, we'll add size to our picture with the size of 40.dp. And we should import dp. Now our picture has a size of 40 dp. We also want to make our picture circular, so we add dot clip to a circular shape. Great, good job. I think that if we add a little bit of space between the picture and those texts, will be great. So to add a space, we use the spacer composable. And we add its width. Let it be 8 dp. Now if we refresh our preview, it will look way better. And did you see what I did? I made a mistake and I set the size of the row to be 40 dp and to be circular. We don't want this. What we want, copy this modifier, cut it and paste it as a modifier of the image. Rearrange the code. We want another modifier for the row. We want to add a little bit of padding. That means space around all of the elements. To add padding, we do the same. We add a modifier, padding of 8.dp, and we refresh our preview. So now it looks better. Also, we can add a little bit of spacer here. And the way we do this is by adding a spacer. This time not with width, but with height of 8 dp. And we refresh our preview. Now you see, after we have added a vertical space between the profile name and the profile description, it looks way better. Thank you for watching. Hello and welcome. In this lecture, we will discuss theming and material design in Jetpack Compose. Jetpack Compose is built to support material design principles. Many of its UI elements implement material design out of the box. Also, Compose makes it easy to give your app a consistent look and feel by applying themes. Material design is built around three pillars: color, typography, and shape. Let's add them one by one. Color. Colors are modeled in Compose with a simple data holding class. You can organize your colors however you like. For example, a top-level constant within a singleton or defined inline. I strongly recommend you to specify colors in your theme and retrieve the colors from there. This approach makes it possible to support multiple themes like dark theme. To see your colors, you go to your package, UI, theme, color. Here is a list of all the colors used in our project. To change or add a color, you type val, your color name, I'll name it blue, and you create a color class with any code you like. I'll add just random color. You can click here and add whatever color you want. I'll stick around with this blue color. If you want to change the material theme colors, you go to theme and change your primary color to the color you want. Alright, now let's style the title and add a border to the image. To add a border to the image, we go inside the image composable and add a border modifier. There's three parameters that we should provide for the border. The first one is width. I will add 1 dp of width. Then we add a color by typing material theme dot colors dot primary. Then we can add a shape that will be a circular shape. Let's refresh the preview by clicking the reload button. As you can see, there is a little border around our image. We can make it larger so it's more visible. So it's time to add the color to our text. We add the color to our text by providing a color parameter. The color of our text will be material theme dot colors dot on background. The same will apply to our description text. Let's refresh the preview. Now the border width is larger. Often we want to vary how much we emphasize content communicate importance, and provide visual hierarchy. Material design recommends employing different levels of opacity to convey these different importance levels. So, if you want to make our description less visible, in order to highlight the importance of the name, we add a composition local provider with the values of local provider, local content alpha provides content alpha dot medium. Remove the values. And inside this composable, we should put the text that we want to be less with less alpha. We put it inside, and we refresh our preview. But there is no difference between those two colors. That's because we have provided a color here, so it doesn't take into account the alpha. Let's change this and reload our preview. So now we have a grayer text than this one. Now we will discuss typography. Material typography styles are available in the material theme. Just add them to the text composable. First, if you want to change the font of our text, we can make it like bigger, or okay, let's take a look. You type style material theme dot typography dot, let's make it a H3 and refresh our preview. You can see that it is way larger than we want, so we can try to make it like subtitle 2 and also add style to our description. Material theme dot typography dot body 2. Let's refresh our preview. You see, it looks way better now. If you want to change the fonts, you can go to your type.kt file. Here you can add other types of fonts. For example, H3, you create the text style and add a font family. Font family dot monospace, font weight dot, for example, medium, and we can also add a font size. With 24.sp. Let's take a look how it looks like. Change this body to H3 and refresh our preview. You can see that our style changes. Let's undo the change because we don't want to look like this. Let's take a look at shapes. With shape, we can add the final touches. We also add a padding to our layout for better user experience. There are several shapes that come out of the box with Jetpack Compose. You can see them all here. Material defines a shape system, allowing you to define shapes for large, medium, and small components. You can see how you define your shapes in the shapes.kt file. Many components use these shapes by default. For example, button, text field, and floating action button default to small, and alert dialog defaults to medium. You can try and play around with shapes, for example with our image shape, and we can clip it in different shapes. Let's check it out. Material theme dot shapes dot medium. Let's refresh our preview. You can see that if I zoom, we are using around the shape as we have defined it here with 4dp corner. There are also other types of shapes, for example the cut corner shape, and we can add it a size of 8dp. Let's refresh the preview. If you don't want to have all your corners cut, you can just specify the ones you want. I want to have cut only the bottom right corner, so I just set it to 16dp and refresh the preview. Now you have only this one removed. And we have the top one removed, and if you want the bottom one, you specify bottom end. And let's decrease the angle. You can see the changes. Let's revert everything to use circle shape. Now let's talk about dark theme, or also called night mode. Dark theme can be enabled to avoid a bright display, especially at night, or simply save the battery. Thanks to the material design support, Jetpack Compose can handle the dark theme by default. Having used material colors, text, and backgrounds, it will automatically adapt to the dark background. Let's see how we can create it. In order to preview our profile card, we can add another preview annotation with the following parameters. To change the UI mode, we set UI mode to equal to configuration UI mode night yes, and we also want to show the background. You can see that another preview has appeared that has a dark background, and this has changed. The last thing we are going to do for this lecture is change the profile picture depending if dark mode is enabled. Go to our image, and inside the painter resource delete the ID, and we'll change it depending on the UI state. If is system in dark theme, this is a method that returns true if dark mode is enabled, and it returns false if it's not. If it is in dark theme, we return r.drawable.profile picture dark, and else we return r.drawable.profile picture. We can remove those braces here. And now let's refresh the preview. You can see that Depending on the UI state, the picture changes. Thank you for the attention. Hello and welcome. In this lecture, we will discuss Jetpack Compose modifiers. Modifiers allow you to decorate or augment a composable. Modifiers let you do these sorts of things. They change the composable size, layout, behavior, and appearance. They add information like accessibility labels. They process user output. They also add high-level interactions like making an element clickable, scrollable, draggable, or zoomable. Modifiers are standard content objects, and to create a modifier, you call one of the modifier class functions. You can change these functions together to compose them. As we saw in the previous lecture, we used a modifier to style the picture like we wanted. First, we added size, then we clipped it to a circle shape, and then we added some border around the picture. Order of modifiers matters. The order of modifier function is significant. Since each function makes changes to the modifier returned by the previous function, the sequence affects the final result. Let's see an example for this. First, we'll head to our profile card. Inside the row, we want to make our row clickable. Let's add the clickable modifier by typing .clickable. Now we have enabled the clickable modifier. Let's run it on our emulator and see what happens. If we click our profile card, we will see that the padding is not clickable. So if we want to make our whole profile card clickable, we should make first the whole card clickable and then add some padding to it. So remove the padding, make the whole area clickable, and then add some padding after it. Now if we rerun it, you will see that everything is clickable, but still we want the whole area to be clickable. So in order to do this, after the clickable modifier, we add a fill max width modifier. Now our whole profile card will fill the screen width. You can see now that the whole area is clickable. If you want to add some padding that is not clickable, we exchange this padding with and add it before the clickable. So now you can see that only the part we want to be clickable is clickable. Also, let's add a shape to the clicking area by writing .clip to rounded corner shape of 4 dp. You can see now that the corners are rounded. Let's discuss the built-in modifiers. Jetpack Compose provides a list of built-in modifiers to help you decorate and augment a composable. Some modifiers such as padding, clickable, and fill max width have already been introduced. Here are some other common modifiers. Size. We have used it in our image composable. Also, offset is quite oftenly used. For example, let's add a little bit of offset on our description composable text. We do it by typing modifier dot offset and add it offset of 4 dp. Now if we refresh, you can see that now there is a little bit of space here, but it looks like like padding, but the difference between padding and offset is that adding an offset to a composable does not change its measurements. The result of our changes is this. The area is clickable, but we would want some spacing above and below the image. To achieve this, we add a padding after the clickable. Now you can see that there is some spacing around the clickable area. Thanks for watching, see you in the next video. Hello, in this lecture we'll extend our already existing project with more exciting features using lists and animations. Lists and animations are everywhere in apps. In this lesson you'll learn how Compose makes it easy to create lists and fun to add animations. First, head to our data class profile and add another parameter that is a list called tags of strings. Then I will paste a list that I created beforehand. You can copy it from the resources of this section. This list will contain different tags that the user is interested in. Alright, then you can comment this out so it doesn't give us an error, and you can delete this. Alright, to create a list we use the composable lazy column. Open curly braces, and inside it type items and make sure it is the ones with the list. Items, profiles, open curly braces. We'll use a name parameter profile inside the lambda, and we'll call our profile card with the value of profile. Let's run and check our app. You can see that our application displays a list of users. Great, but this is not all we want here. We want to display our list of tags. To display our list of tags, we go inside our column, and under the composition provider we create a lazy row. This is the same as the lazy column, but items are displayed horizontally. Inside the lazy row you do exactly the same as we did inside the lazy column. Items, select the one with the list, items.profile.tags, open curly braces, and name the parameter, for example, tag. Create a text composable with the text equal to tag. Then we are gonna add some modifier to it. We're gonna add padding of 4 dp. Then we'll add some border with 1 dp width. The color will be material theme dot colors dot primary color, and the shape will be a rounded corner shape with corner radius of 1 dp. And let's add some more padding. Great, let's run the app. You can see our tags now, but we want to customize them a little bit and not always display them. We should only show them when we click on our user card. But first let's change the font. adds a style of material theme dot typography dot body2. Okay, great. Now it comes the more complicated part. It's time to play with animations. We'll add the ability to expand the profile card to show the tags, animating their visibility. To store the local UI state, we need to keep track of whether the profile card has been extended or not. To keep track of this state change, we have to use functions remember and mutable state of. Let's check how we do this. Is expanded by remember, and inside the remember type mutable state of false. Alright, then inside our click listener of the row, if we click, we'll make set the value of if is expanded to be equal to not is expanded. Alright, and then we should animate the visibility of our lazy row of tags. To animate the visibility, we use the animated visibility composable, and is visible is set to is expanded. Inside the animated visibility, we cut and we paste our lazy row. But animated visibility is an experiment animation API, so we should annotate our profile card with experimental animation API. And also we should annotate our onCreate method with it. Let's run the app and check it. Alright, so now if we click on a profile card, you can see that the tags row animates. Great. See you in the next lecture. Hello. In this lecture, you're going to learn how state works in Jetpack Compose. First, open your build grade file and let's paste some dependencies that you can find in the resources of this lecture. Paste them and sync the project. Go to main activity. Let's create a very simple example. Create a composable function called greeting content. The user can enter their name and they will be greeted. We have a text for the greeting and a text field for the input. Column, let's add some padding of 8 dp. Create a text composable with text hello and an outlined text field with value of empty string and on value changed empty block. Also add a label, open curly braces, and inside it text composable with the text of name. Let's run our app. But first, we need to add our greeting content inside the set content in our main activity. Let's run our app. Now that our app is running, we can see that nothing happens. That's because the text field doesn't update itself. We need to pass a value to it that represents the state of the text field and then update the state when the text field notifies us about the change. So let's introduce a local variable that holds the name that should be displayed. To do this, we'll use remember mutable state of with the default value of empty string. Import remember, and we also again press Alt plus Enter to import get value and mutable state of. Also we need to import the runtime. Mutable state of creates a mutable state which is an observable type in Compose. Any changes to its value will schedule a recomposition to composable functions that read that value. We need to add our name inside the greeting text using $name. Also inside our text field the value should be name, and on value changed we should set the value to it. Remember helps us preserve the state across recompositions. If you use mutable state of without remember, every time the greeting content composable gets recomposed, the state gets reinitialized to an empty string. We can use our remember value as a parameter in other composable functions or even as logic if something should be displayed. We don't want to show our greeting text if the name is empty. To do this, we just write if name is not empty and put our text inside the block. Now it won't be showed if the name is empty. Let's run our app. Now you see that we don't display the greeting if the name is empty. Let's write something here and see the greeting. You can see that it automatically updates. Alright. While remember helps us retain state across recomposition, the state will not be retained across configuration changes. For this, we have to use remember savable. Right now, our composable holds its own state. This makes the composable hard to reuse and hard to test. So we need to make a stateless composable, a composable that doesn't hold any state. To do this, we can use state hoisting. State hoisting is a programming pattern that you move the state to a color of a composable. A simple way to do it is by replacing the state with a parameter and use functions to represent the events. In our case, we create another composable function called greeting screen. We move our variable name inside our greeting screen and we provide the name as a string and a lambda function called onNameChange that takes string and returns unit. So we provide onValueChange to be onNameChange. In our case, we extract the name and onValueChanged out of greeting content and move them higher to the greeting screen composable that calls greeting content Greeting content has access to the state as an immutable string parameter as well as a lambda onNameChange. Lambdas are the most common way to describe events in a composable. Our lambda takes a string as a parameter. The state goes down from the greeting screen to our greeting content, and the events go up from our greeting content to the greeting screen. This makes Greeting content more testable and reusable. Let's check it. Remove the greeting content from the set content and replace it with greeting screen. Let's rerun the app. You can see that it works again, but now, as I said, greeting content is easier to test and it's more reusable. What if we want to use the name in other layers of our app? For example, to save it in a database. The best way to do is to store our name inside a ViewModel. Let's create a greeting ViewModel that extends the ViewModel class. The ViewModel holds and exposes the name as live data, which then can be observed as state and passed to our composable. Every time the data changes, it will trigger recomposition. Let's create a live data private val underscore name that is equal to mutable live data with a default value of empty string. And let's expose the name by typing variable name of type live data of type string is equal to underscore name. Import live data. Our greeting screen will take the greeting view model as a parameter. Let's initialize the view model up here. And provide the greeting view model to our greeting screen. As the view model survives configuration changes, we don't need to do anything else to persist our data. Also, we need to hoist the event handling to our view model. Let's create a function called onNameChange that takes the new name as a string and sets the value of underscore name to the new name. We don't need this remember savable anymore, but we provide our name by writing val name, which is a string, by greeting view model dot name dot observe a state with an initial value of empty string. This won't work now, and we need to provide our greeting view model on name change to our greeting content. Let's rerun the app. You can see that everything works properly. Thank you for watching. Hello. In this lesson, we are going to learn about the Scaffold and SWOT API and how to use them to design a fully functional screen in Android application. You will learn how to create a top bar, a button navigation view, a drawer, and the main content of the screen. Most importantly, you will learn how Scaffold holds all of them together. Alright, let's get going. I have prepared some vector drawables, so we want to get them from the resources of this lecture and paste them inside the drawable folder. First, let's create a composable function with the name of scaffold example. Inside our scaffold example, we'll create the scaffold layout. Here it is. You can press Ctrl+P to see all of its parameters, and there are quite a lot. I'll go through the most oftenly used. First, the modifier. As the name suggests, the modifier's way to modify a certain aspect of the component. The scaffold state is the state of the scaffold composable. It contains the basic screen state, for example the drawer configuration, as well as the sizes of components after the layout has happened. Basically, it's used to get the state of the drawer and to execute operations like open, close, and more. Top bar. It's simple composable function to design the top bar of the app. Bottom bar. This is used to show the bottom navigation view on the screen. And snack bar host. To handle the snack bar effectively with existing UI, we need to use snack bar host. Floating action button, floating action button position, and is floating action button docked. Those parameters are used to create a floating action button. Drawer contents. This is simple composable function used to design the drawer layout. Okay, let's create a basic scaffold. First, let's add the contents of the scaffold. We create a box, a simple box that fills the max size of the layout, and inside it we'll add a simple text composable with scaffold content. Alright, first let's create the top bar. Top bar is nothing but the toolbar that we use to show at the top of the screen. Let's design a simple top bar. Let's create a composable called top bar, and it will accept several parameters. First, the scaffold state, and also it will accept a coroutine scope. Inside it, create a top up bar with the title of text scaffold example, and the color should be white. You can change the color however you want. Also, let's add a navigation icon. That is open curly braces, and add an icon button with an on-click action of that is scope.launch, and inside the coroutine block we type scaffold state dot drawer state dot open, and let's add the icon. To get the icon, we use painter resource with the ID of r.drawable.menu, and content description is just menu. Let's add a little bit of elevation. On the click of the menu icon, we need to open the drawer using scaffold state.open, which is a suspend function. So we need to use a coroutine scope. Okay, let's continue to create our very simple drawer content. Again, create a new composable function. Call it whatever you want. And inside it, just add very simple elements like I'll just display some very simple text composables. We are ready with our drawer content. Then let's create a data class that will save the bottom bar items. It will have a title of type string and also an icon of type int that we should annotate with @drawable_res. Let's create again a new composable called simple bottom bar. Inside our simple bottom bar, let's create a list of all the bottom bar items. The first one will be called home with an icon of r.drawable.ic home. Copy this several times. The second will be search with the icon of ic search. The third one will be favorite with an icon of ic favorite. And the last one will be profile with a drawable of ic person. Let's create the bottom navigation. Let's add an elevation inside our bottom navigation of 8 dp, and inside it let's add items dot map bottom navigation item and selected false, and we won't do anything on click. Also, we will add an icon that is equal to the content will be icon with painter resource of it dot icon, and we won't have a content description, or let's add it dot title. Also, we'll add a label. The label again will be a text composable with the text of it.title. Press Ctrl Alt plus L to format your code. Also, let's add a selected content color, which will be color.white, and unselected content color again will be color.white, but with a lower opacity of 0.4f. And we are almost ready. Now that we have designed the subcomponents, it's finally time to bring them all together inside our scaffold. Now we need to create scaffold state and coroutine scope using remember to maintain the scope across recomposition. Using remember scaffold state and also scope is equal to remember coroutine scope. Get inside the braces of scaffold, and we need to provide the scaffold state. Also the top bar. Provide the scaffold state and the scope. We need to add our drawer content. And we also want to add a bottom navigation. Bottom bar is equal to simple bottom bar. And we should add our scaffold example composable inside the set content. Let's run our app. Here's our app. We have a drawer with all 5 items. We have a bottom navigation and a top bar, and this is our scaffold content. Thanks for watching. Hello, in this lecture I'll talk about side effects in Compose, what they actually are and what we can do with them. Essentially, they're everything that escapes the scope of a function. It can be something simple as incrementing a variable or creating a network call. Let's say that you create a network call outside side effect. It will get called every time the composable function is recomposed. But we want to make such operations as querying a database, creating a network call, or as simple as incrementing a variable, which is not a state. We need a safe place to do these things. This is where effect handlers come into place. Compose comes with a bunch of these handlers, and now we'll go through the most important of them. The simplest one is called side effects. The block inside side effects is called on every recomposition. Let's check it how it works. Let's create a composable function and call it whatever you want. Let's create a button with an empty click list, empty on click, and inside just some text like hello. For example, we have one public variable called my variable with the value of 1. And for example, we want to increment that variable inside our composable functions. We can do it this way, but this is not a best practice. What we should actually do is open a side effects block. And move our variable incrementation inside the side effect block. This is how side effect works. Sometimes you have blocks of code that require some kind of cleanup after a composable finishes composing, and we cannot use side effects. Instead, what we need to call is called disposable effect. The following example is from the Android documentation. First, let's get a back press dispatcher that is passed outside our composable. This back press dispatcher is called when we click on the back button. We want to override the back press callback. To create the callback, we use a remember block. import remember, and inside create an object that is on backpressed callback and enable it. Open curly braces and inside override handle on backpressed. Here normally you would do your operations. Then let's add the callback to the backpress dispatcher. This way, we'll add a callback on every recomposition, but we won't remove it. This will cause memory leaks, and we should be very careful with it. We need to use disposable effect. It requires a key, so we pass our backpress dispatcher, open curly braces, and we should move this block of code inside our disposable effect. Now we will get an error. A disposable effect must include onDispose clause as its final statement in its block of code. Inside this onDispose, we should use callback.remove. So this block of code is only code when backpress dispatcher changes. The effect is disposed and restarted again. The last thing we will be discussing is launched effects. To call a suspend function safely from inside a composable, use the launched effect composable. When launched effect enters the composition, it launches a coroutine with the block of code passed as a parameter. The coroutine will be cancelled if launched effect leaves the composition. If launched effect is recomposed with different key, the existing coroutine will be cancelled and the new suspend function will be launched in the new coroutine. Let's check an example using a snack bar inside a scaffold. I'll write this example inside the set content. Let's get a scaffold state. Using remember scaffold state. Let's create our scaffold layout. And inside it, let's add a button. It will increment a simple variable. Var count by remember mutable state of 0. And we increment count when the button is clicked. Let's add a text inside the button. Great. Now we have a button that is incremented, which its text changes when the button is clicked. But let's say we want to show a snack bar every time the count is divisible by 3. To do this, we use the launched effect with the key of scaffold state dot snackbar host state and remove the block. Open curly braces. Inside it, call scaffold state dot snackbar host state dot show snackbar with the text $count is divisible by 3. Now every time we click the button, this will show, but we only want to show it if count is divisible by 3. And we should add the state to our scaffold. Let's run it and see. When we click on the button, the text is incremented. And now we should see the snack bar. Here it is. In the code above, a coroutine is triggered when the state, the count, is divisible by 3. And the coroutine will be cancelled when the count is not divisible by 3. As launched effect, call site is inside an if statement when the statement is false. If launched effect was in composition, it will be removed, and therefore the coroutine will be removed. Thank you for the attention. Hello, in this lecture you will learn about Compose navigation. Here we have an empty Android Compose project. First, what we're gonna do is open the build Gradle file that is the module. I will paste the necessary dependencies. You can find the dependencies as a resource in this lecture. We'll need the navigation compose dependency. Click sync now. We will build a very simple application that has 2 screens. On the first screen you enter some text, and on the second screen we will display it. Let's get started. First, click on your package, right click, go to new package. Call it whatever you want. I would call it screens. Inside it, I will create a Kotlin class or file. Select a file and call it main screen. Inside it, we'll create a composable function called the same, main screen. Then we need to create a second screen. Again, select Kotlin file and call it second screen. Create a composable function called the same as the file. Alright. The navigation component provides support for Jetpack Compose applications. You can navigate between composables while taking advantage of the navigation component's infrastructure and features. So go to our main screen and we will need to add a nav controller as a parameter. This will be passed from the outside. Let's create a column with a modifier of fill max size, and let's center our contents with vertical arrangement center and horizontal arrangement center horizontally. Then inside, what we want to create is a text field. Above it, let's add the text state. Val text open braces, and inside type text set text that is equal to remember mutable state of empty string. Import remember. the value should be text, and the onValue change should be setText. Then we'll add some spacer and create the height to be 8 dp. Below it, let's add a button with an empty onClick for now, and the text should be go to second screen. Alright, then for the second screen, it will take a text as a parameter. The text will be string. It will be a very simple layout, just a column with fill max size and center content. Then inside we'll just have one simple text composable with the text equal to our text parameter. Very well. Now it's time for the more complicated part. The nav controller. The nav controller is the central API for the navigation component. It is stateful and keeps track of the backstack of composables that make up the screens in your app and the state of each screen. Let's create a navigation Kotlin file called navigation. Inside it, create a composable called navigation. You can create a nav controller by using the remember nav controller method in your composable. Now we should create a nav host. Each nav controller must be associated with a single nav host composable. The nav host links the nav controller with the navigation graph that specifies the composable destination that you should be able to navigate between. To create the nav host, just type nav host and nav controller, provide the nav controller, but we won't need a graph, rather we will need a start destination. The start destination, also called as route, is a string that defines the path to your composable. You can think it as an implicit deep link that leads to a specific destination. Each destination should have a unique route. So our start destination will be called main. Open curly braces. To construct your navigation graph, you should use the Composable function. The route for the first composable will be main, open curly braces, and inside we call our main screen, and we should provide our nav controller. For our second screen, again we create a composable with a route of second, open curly braces, and type second screen. But we see that the second screen needs a parameter. But where do we get this parameter from? Navigation Compose also supports passing arguments between composable destinations. In order to do this, you need to add argument placeholders to your route. So here we add a slash, and inside curly braces we add a placeholder called text. Here we need to type nav backstack entry. To get the text that we want to provide, we type val text is equal to nav backstack entry dot arguments question mark dot get string with the key of text. But if we press Ctrl plus Q, we can see that our string is nullable. So we add a question mark and a semicolon. If this is null, our text will be just an empty string. Now the text is not nullable. So we provide it. We are almost done. We just need to call our navigation composable function from our main activity. And we are ready. So go to our main screen, and as you probably remember, we have left our on-click empty. So we should use our nav controller that is provided from our navigation function, nav controller dot navigate to the required destination. So as you remember, our destination is called second with a slash, and we need to provide our text argument. And our text argument is this one here. So $sign text. Now everything should be set. Let's rerun the app. Let's test it again. And press go to second screen. You can see our text here. Let's check it again. And press go to second screen. Perfect! It works. Thanks for watching. In this section of the course, you will build your first Jetpack Compose app. Here, you will learn how to connect your app to the internet and get information that is not stored inside the device. The app you will create is a weather app. You can enter a city and get information about it. For example, you get the temperature, the minimum temperature, and the max temperature. Also, you'll get information about the humidity and whether it is sunny or cloudy. Let's get started. In this lecture, I will show you where you will get the weather data from. Open Google and type open weather map and click this link, openweathermap.org. Open Weather Map is an online service that provides global weather data via an API, including current weather data, forecasts, and historical weather data for any geographical location. You need to create an account. Click here, sign in, create an account. Enter your username, email, password, and click those checkboxes. After you've done that, click here, sign in, enter your email and password. And click submit. You will be greeted with this page. You want to go to the API keys. We need this key so we can access the weather data. Remember it or copy and paste it because we will need this in our next lecture. Thank you for watching. Let's start by creating the project and adding the necessary dependencies. Click Create New Project and select Empty Compose Activity. Click Next. Select the name. I'll call it My Weather App. Select your package name and the location. Click Finish. Once the Gradle build is finished, you will be greeted with an empty Compose project. you want to go to the Gradle script, the build.gradle file up level. Here, you want to paste some dependencies. All of the dependencies will be available in the resources section for this lecture. Alright, so first copy the Dagger.Hilt.Android plugin and the Kotlin capped plugin and paste them up here. Then copy all of the other necessary dependencies and paste them here. You will need to have the compose dependencies, the coroutine lifecycle, the Dagger Hilt retrofit, and also live data. Then go to the build.gradle module level and copy and paste the Dagger Hilt dependency. Click sync now. Also, we want to add the necessary pictures for our weather state. You can find them in the resources of this lecture. Copy all of them. Copy them. And then go to the resources, drawable, right click, and select paste. Select the drawable folder. And you should see them right here. Great, see you in the next lecture. In this lecture, we will connect the app to the internet. First, open your manifest file. We need to declare that our app uses the internet. In order to do this, just type uses permission android.permission.internet. Then open your browser and go to openweathermap.org. Go to API, and here we will need the current weather data, and click API documentation. Here you can see how we can call the API in order to get the response we want. We want to pass the city name and your API key. Also, there are additional parameters that we can use. For example, the units. Do you want them to be standard, metric, like Celsius or Fahrenheit? Copy this link and paste it inside the browser, and I'll show you the response to searching for London and my API key. Here you can see the JSON response. You should copy it, Ctrl C. Then head back to Android Studio, and inside our main package, right click, new package, and call it data. For our next step, you'll need a plugin called JSON to Kotlin class. So press Ctrl Alt plus S and go to plugins. You'll need this one here. If you don't have it, go to Marketplace, install it, and then restart Android Studio. Once you have done that, go to Data Package, right click, New, Kotlin Data Class from JSON. Paste our response. You can click Format, and the class name should be called City Weather. Click Generate. Now you see that our program has generated several classes that represent the JSON that we have received. Next, you want to create another package called util, in which we'll create another Kotlin file or class that will be an object. In this file, we'll store our constants. The first constant will be our base URL. The base URL will be https api.weathermap.org.data/2.5, and the other one will be our API key. Go, copy your API key and paste it. What you want to do next is to create our interface that will be used for retrofit. Click New, inside the data package, New, Kotlin file or class, interface, call it Weather API. Click Enter. We'll have a suspend function called getWeather for city. Open braces. As you saw, our query needs several parameters, like the location and our API key. So, in order to provide them, we annotate our parameters with @query. The name should be as it was in the website. For the city, it was Q. Call it city, which will be string. Then we need another query parameter called app ID. This is our API key, which is also a string, and we get this from our constants constants.api key. And also we want another query parameter. As I've mentioned earlier, it's called units. It will be a string and it should be equal to metric. Our function should return a response of type city weather. But we are not done yet. We should annotate our function with @get from retrofit.http. Well done. See you in the next lecture. In this lecture, you will learn what dependency injection is and how to implement it into your app. Dependency injection is a technique widely used in programming and well suited for Android development. By following the principles of dependency injection, you lay the groundwork of a good app architecture. Implementing dependency injection provides you with the following advantages: reusability of code, ease of refactoring, and ease of testing. Classes often require references to other classes. For example, a repository or a ViewModel might need a reference to an API. The required classes are called dependencies, and in our example, the repository or a ViewModel class is dependent on having an instance of our API to run. Dependency injection provides your app with the following advantages: reusability of classes and decoupling of dependencies. It's easier to slap out implementations of a dependency. The code is reusable Code reuse is improved because of inversion of control, and classes no longer control their dependencies and how they are created. And also ease of refactoring. Dependencies become a verifiable part of the API interface, so they can be checked at object creation time or at compile time rather than being hidden as implementation details. Let's get to our project. First, you need to create a new package. Let's call it DI, that stands for Dependency Injection. Here, you need to create a new Kotlin file or class that will be object, and let's call it app module. Here, we declare all of our dependencies. Our app module should be annotated with @module, and also should be annotated with install in annotation into the singleton component. What this means is that all the dependencies that we have declared will live as long as our app is alive. Alright, here we need to provide our weather API. We create a function called provide weather API that doesn't take any parameters, and we will return a weather API, open curly braces, type return retrofit dot builder dot base URL, and we will use our constants dot base URL. Also, we'll add a converter factory called JSON converter factory. Dot create. Also call build on that, and then again create. What we want to have is weather API dot class dot java. This way we provide our weather API and don't need to write this code every time we need it. Also annotate our function with @singleton and with @provides. Also, we need to create another class inside our main package. So right click on it, new Kotlin file or class, call it my weather app, and click enter. It will extend the application. We need to annotate our app with @Hilt Android app. Then go to the manifest folder, and inside the application type Android :name equals .myweatherapp. This shows that our app is a Hilt Android app. And one last thing we need to do is go to our main activity and annotate it with @Android entry point. This is how simple dependency injection is. Thank you for watching. A vital part in Android development is theming our apps. The user wants to use something that is aesthetically pleasing and easy. Our app will support dark theme. So, let's get started. Open your main package, then go to the UI package, and inside our theme, we will find the color.kt file. Here, you should list all of the colors that your app is using. In our case, I want to use other colors. You can find them in the resources of this lecture. I'll delete those and paste my selection of colors. If you don't like my design and color choices, I'm sure that you enjoy choosing your own colors. Don't be afraid to experiment and play around. Then go to the theme.kt file and you see some errors here. The first one, our primary color will be called, and also that this is our dark theme, will be called blue dark. Our primary variant will be called blue variant dark, and our secondary color will be orange accent dark. The same will be in our light colors. It's called blue light, blue variant light, and also orange accent light. Also, you can change the shapes and their corner radiuses, or add another shape, like for example cut corner shape, or whatever shape you like. I'll keep it with the cut corner shape. Also, you can change the type of your app, its font sizes, and its font families. As I said, don't hesitate to change the colors and try your own ideas into the design. You will not regret it. See you into the next lecture. In this lecture, we will create the repository that we need in our app. But what is a repository, you will ask? A repository is a class that acts as a data access layer. It will provide all the necessary data to our ViewModel. It helps to decrease boilerplate code and duplicated code. First, in our project, in our YouTube package, I'll paste a class called resource, which is almost always used when dealing with remote data. You can find this class in the resource of this lecture. Then create a new package called repository. Inside the repository, create a new Kotlin file or class. It will be called weather repository, and in its constructor it will take private val weather API. As you remember, in the dependency injection video, we provide our weather API, so we don't need to create it manually. In order to do this, we just annotate the constructor with @inject. Inside our repository, we will have a suspend function called getWeather for city that will take the city as a string, and it will return a resource of type cityWeather, open curly braces. Return, and we return a try block. Let's create our response object, and we'll get it by calling our weather API .getWeather for city with the city provided. Then we will check if the response is successful. If it was successful, we will return a resource .success with the response .body. If it wasn't successful, we return a resource .error with the message will be response .message, and data will be null. And if something happens, we'll catch it as an exception, and again return a resource dot error with the message couldn't connect to the servers. Check your internet connection. With the data, no. That's all for our weather repository. Also, we will need to provide our weather repository to our ViewModel that we haven't created yet. So go to our app module and again create a function called provide weather repository. This time our function will take a parameter, the weather API that we have created here, open curly braces, and we will return weather repository with our weather API. We forgot to mention that our function will return a weather repository. Don't forget to add the @singleton annotation and @provides annotation. Thanks for watching. In this lecture, we'll start creating the navigation for our app. As you see, in the Ready app, we have two screens. One that you select and type the city you want to search for example, New York. And the other is the weather screen. Let's start implementing this. In the UI package, create a new package called choose city. Inside it, create a Kotlin file or class, it will be a file, and call it choose city screen. Create a composable and call it choose city screen. It will take a nav controller as a parameter. And let's have a very simple text inside it. Create a column and some text. The text will be choose city. Alright, then go back to the UI package, select new package. This time it will be called weather city. Click enter, and again create new Kotlin file or class, call it weather screen. Select file, create a composable with the same name. The composable will accept a city as a string. Again, create a column with some text inside it. Then, again in the UI package, right click new package, call it util. Here we will create two files. First of all, new Kotlin file class will be a sealed class, call it screen. It will have a parameter called route, and it will be string. Open curly braces. Inside it, we will declare our two screens. One is choose city screen. It will extend screen with the route of choose city screen, and the other one duplicate it, Ctrl D, weather screen, and the route will be weather city screen. With a backslash. Then create a new Kotlin file or class inside the util package. Select a file, call it navigation. Create a new composable, call it navigation. Inside it, create a nav controller. By using remember nav controller. Create a nav host with the nav controller equals to nav controller. When we don't need this graph, we'll need a start destination. The start destination will be our screen dot choose city screen dot route. Open curly braces. Inside our nav host, we'll list our screens using Composable. Select the route to be screen dot choose city screen dot route. Open curly braces. And we'll call our choose city screen with the nav controller. As you know, the second screen needs a parameter city. Let's create another composable with the route of screen dot weather screen dot route plus open quotation marks, then curly braces, and type city. Open curly braces, and here name the parameter nav backstack entry. To get the city, we use val city equals nav backstack entry dot arguments question mark dot get string. The string will be city, and if it happens this to be no, the default value will be New York. And we'll call our weather screen with city. Go to main activity, and you can delete these composable functions. Here you can create a box with a modifier of modifier.background. The background will be a brush dot linear gradient with the colors of let's use our material theme dot colors dot primary and also material theme dot colors dot primary variant. This will give us a very subtle gradient. And here we'll call our navigation. Let's run and test the app. You can see that our navigation is working. It is displaying the choose city. Currently we can't navigate to the next screen, but in the next lecture we will create the layout for the choose city screen. See you into the next lecture. In this lecture we'll start implementing the choose city screen. First of all, let's start in the column. We want a horizontal alignment to be alignment.center horizontally. And also vertical arrangement, we want to be arrangement.center. Also, we want to add a bit of modifier of fill max size and a padding of 24 dp. Import dp. Then change this text to here to my weather app. Add a spacer with height of 16 dp. Then create a text field. We will need a value and on value change. We'll create them up here, val city name and set city name. This should be equal to, remember, mutable state of empty string. Import, remember, the value has to be city name. Here open curly braces, set city name to it. Also, we want to have a modifier of fill max width and we want to clip a rounded corner shape of 8 dp corner radius. Also, we want to change the default colors of our text fields. We do it by text field default dot text field colors. This is a bug in Android Studio, so remove it. And here we'll change the background color to material theme dot colors dot background. Here you can see that there are a lot of other possible colors, for example the cursor color or whatever you want. Also, we want to add a label. The label will consist of a very simple text field. Its text will be city. And we want to add also a text style. It is equal to text style. The font size will be equal to 16.sp and import it. Below our text field, I'll add a spacer, again with a height of 16 dp. Below it, let's create a button with an empty on click for now. I want to customize it a little bit, so let's add a color. It will be equal to button defaults dot button colors, again the Android Studio bug. The background color should be equal to material theme dot colors dot secondary. Also, let's add a shape to our button. It should be equal to rounded corner shape with 8 dp. And a modifier of fill max width. The text of the button will be choose. And now the on click will be the following. If our city name is not blank, we want to navigate with nav controller dot navigate to our screen dot weather screen dot route plus city name. Let's run and check the app. you can see how our app looks like, but this text is a little bit small, so let's make it a bit bigger. Go to the text and add a font size equal to 24 sp, and let's format it a little bit. I said that our app will have a dark theme. Let's test it out. If you don't see any night mode here, go to this pen here, and it should be here, dark theme. Drag it up and place it, and click the back arrow. Now let's enable dark theme and see how our app looks like. You can see that everything now looks a bit darker, so it's more comfortable for the user. See you in the next video, where we'll make the weather screen. Hello, in this lecture we'll finish off our app by creating the weather screen and the weather view model. First off, let's start by making sure that our navigation works properly. As you know, our weather screen needs a city that gets passed from the choose city screen. Let's print it. In our text, change the weather screen to weather screen for city, and print the city we receive. Run and test the app. Let's enter a name for the city and click choose. You can see that New York gets printed. Great, let's continue. In our weather city package, right click, create new Kotlin or file, and name it weather view model. Select a class. Our view model will need a weather repository. Private val weather repository, and it will be injected. So type add inject and import it. Our weather view model will extend view model. First, let's create a function to get the weather for the city. It will take the city name as a parameter. It will be a string. And let's type ViewModel scope.launch. And here we will need a state that will be our city weather. Private val underscore city weather. It is equal to mutable state of. It will be of type resource of type city weather, and initially it will be equal to resource.loading with no data, and then we will need to expose the state city weather. It is of type state of Android X compose.runtime, of type resource, of type city weather, and it will be equal to city weather. In our get weather for city function, we'll set the value for city weather to our weather repository dot get weather for city and provide the city. This is all for our view model. Let's get back to the weather screen. Here, let's remove the text. Our column will need some modifiers. First, I want horizontal alignment to be center horizontally. Also the vertical arrangement will be center. And let's add a bit of modifier of fill max size. And let's add some padding of 24 dp. Import dp. We need to change the signature of our function. We need also a view model of type weather view model. It should be equal to Hilt view model. But how do we code a view model? We use launched effects, as you probably remember from the Jetpack Compose tutorial. The key will be city. And open the block and call ViewModel dot get weather for city and provide the city. Here inside our column, let's create a when expression when the ViewModel dot city weather dot value dot status is here Alt plus enter and press add remaining branches. For each of those statuses we'll write different code. Let's start with the success. If our request was successful and we have value, we'll create a text with the text equal to viewModel.cityWeather.value.data. Let's create a no check and get the name of the city. And if it happens to be no for some reason, we'll provide the city that we have received from our choose city. And let's change the font size 48.sp. Import the sp. Also, let's add an image. The painter should be equal to painter resource, and this part is a little bit tricky. It will be equal to when our view model dot weather city weather dot value dot data question mark dot weather again question mark dot first and again question mark dot icon open curly braces. Here I'll copy paste a code that you can find in the resources section of this lecture. We have unnecessary bracket here, so remove it. We need to import our imported, and then we also need to add content description, which will be just empty. Close the bracket here. Also, we want to set a modifier for the picture. Modifier dot size of 256 dp. Import size. Then add a text that should be equal to $, open curly braces, viewModel.cityWeather.value.data question mark dot weather again question mark dot first, again question mark description, and the font size should be around 32 sp. Then we will create another text, but this time we want to use build annotated string. Type with style of style equal to span style with color blue. Open curly braces and type append open quotation marks and dollar sign and curly braces. ViewModel.cityweather.value.data question mark dot main, again question mark dot temp min, and add a degree sign. Then outside this style append quotation marks, then a straight line, and again some space. Then type with style. This time the style will be equal to span style with the color red. Open the block, and the code should be almost exactly the same, so you can copy it and paste it here, and instead of temp min, select temp max. Then we can change the font size. Let's set it to 32 sp. For example, also we can display the humidity by again creating a text composable, and the text will be equal to quotation marks humidity colon dollar sign curly braces ViewModel dot cityweather dot value dot data question mark main, again question mark dot humidity, and we should add a percent sign because humidity is displayed in percentage, and add a font size of 32 sp. Then for our status.error, we would just display a simple text field equal to viewModel.cityweather.value.message, and if the message happens to be null, we'll say an unknown error occurred. And the font size will be 16 sp. And if the status is loading, we'll display a very simple circular progress bar. That's all for our weather screen. Let's run and test the app. Let's start by getting the weather in London. And our app crashes. We forgot to annotate our view model with @Hilt view model. That's very important step. Let's run again and test the app. Let's type again London and click choose. You can see that we get an error, could not connect to the servers. Check your internet connection. But the reason for this error is not really because we don't have internet connection, but because we haven't specified where we should get this data from. Now our app is trying to get the information from the base URL, but we want to get it from the base URL plus weather. So type here weather. Run and test the app again. Let's test it for a third time. You can see that debugging and testing is a vital part of Android development. Now it works properly. It says London, it's broken clouds, its minimum temperature, its maximum temperature, and that its humidity is quite high. Let's turn the dark mode. You can see that it's a bit darker now. And what happens if we go back and turn on airplane mode? Let's search for another city, New York. And although I have turned on my airplane mode, my Wi-Fi is still on, so turn it off. And in my case, the Wi-Fi doesn't turn on off for some reason, but on your emulator everything should be fine and it should display the error message. That was all for this section. Thank you for watching and I hope you learned quite a lot. See you into the next section. In the last section of the course, you will learn how to create a to-do app with Jetpack Compose with MVVM architecture. You will learn how to save user data locally on the device using a database called Room. Also, I will show you a very simple way of creating custom dialogues. Let's check out the app that we will create. You can see that our app has a small title, My To-Dos, and under it you'll see that a simple text that says no to-dos for you. Click on the plus sign to add new to-dos. So we click our floating action button and a dialog appears. Here we can add our new tasks for the day. Task 1, and then we click save. And here is our first task. Let's add several more tasks. If you've done one of these tasks, you can just click it to mark as done. Then if you don't need this task anymore, you can just click the delete icon and it will be removed. This is the app we will build. See you into the next lecture. Alright, let's start by creating the project. Click New Project. Select Empty Compose Activity. Name your project however you want. I'll call it To-Do App and select the directory. Once you've done that, click Finish. When your build is done, go to Gradle Scripts and to the project level build Gradle file. I will copy and paste a class path and you have all the necessary dependencies in the resources section of this lecture. Then go to the other build Gradle, that is the app level. First here, add the Kotlin capped plugin and the Hilt Android plugin. Our app will need several libraries, so copy all of them, select these and remove them, and then paste the new ones. We'll use Room, again Dagger, Hilt, and some other compose dependencies. Click Sync now. We will continue our work in the next lecture. Hello, in this lecture we will start by creating the database we need for the to-dos. We will be using Room database. But what is actually Room? Well, Room is a library that simplifies database work. It is an abstraction that sits above SQLite database. First, let's start by creating the entity class, which is an annotated class that describes a database table when working with room. Go to our base package, right click, select new package. Let's call it data. Inside our data package, again right click and create a package that's called local. Here we'll create our entity. Let's call it to do item and select a date class. Here we'll annotate our class with @entity that comes from Android x.room. Our to do item will have several parameters. First, we'll have a content which will be string. Another thing that we'll have is a boolean called isDone that will show whether we have completed our task for the day. Initially it will be false. And finally we'll have a primary key called id, which will be a nullable int, initially equal to null. Then we should proceed to creating the DAO, which stands for Data Access Object, a mapping of SQL queries to functions. When you use a DAO, you'll call the methods and room takes care of the rest. Again, in the local package, right click, new, Kotlin file or class, and select interface. Call it to do DAO. This interface has to be annotated with @DAO that comes again from androidx.room. Here we'll have several other different functions. The first one will be a suspend function called insert to do item. It will take a to do item as a parameter. And here we should annotate this function with @insert. This annotation tells room to generate the necessary code behind the scenes. Open brackets, and inside it we should specify an on-conflict strategy. This strategy is used when there is an existent to-do item with the same ID. We'll be using an on-conflict strategy of replace. So if we have a duplicate item, we'll replace it with the new one. Then again we'll create another suspend function, call it delete to do item, and again we'll get a to do item as a parameter, this time annotated with delete from androidx.room. This delete annotation tells room to generate the necessary SQL code for deleting an entry. And finally, create a regular function, not a suspend one, called getToDoItems. It won't take any parameters, but it will return a flow from Kotlin x.coroutines.flow. Be very careful which package you select. It should be this one here. The flow will be of type of list of to-do item. We are not making our function suspend because flow is already asynchronous. And finally, we should annotate this function with @query. This time we should specify what we want our query to be. Open quotation marks and type the following query. Select star, this means everything, from to-do item. This is all for our DAO. We have a function to insert a to-do item, to delete to-do item, and to get all the to-do items. Then we have to create the room database. Right click in the local package, again Kotlin class or file, select a class, call it to do database. This class should extend room database and should be marked abstract because room will extend it under the hood. Here we'll have an abstract value of to-do-DAO, which will be of type to-do-DAO. And then create a companion object, and inside this companion object we'll store a constant val database name and call whatever you want. I'll call it to-do underscore db. Finally, we should annotate our database with @database. Again, from androidx.room. Open braces. We need to provide several parameters. First, the entities. This tells room what tables it will have. Open square brackets, and inside it type to-do item colon, again colon class. And also we need to provide a version. This is our first version of the database. And finally, let's create the repository which is used to manage data sources. In our base package, right-click, new package, call it repository. Right-click and create a Kotlin class or file. Call it to-do repository. Our repository will take our DAO as a parameter of type to-do DAO. Inside it we'll have several functions. The first one again will be suspend function called insert to-do item, and it will take a to-do item. This function will call our DAO dot insert item and provide our to-do. Then again we need another suspend function called delete to-do item. It will take the to-do item as a parameter, and we'll call our DAO dot delete to-do item with to-do item. Finally, we need another function called get to-do items. That will be equal to DAO dot get to-do items. That's all for our repository. In the next video, we will implement Dagger Hilt dependency injection. See you in the next lecture. Let's start implementing dependency injection in our to-do app. First, we need to create application class in our base package. Right-click and create new Kotlin class. Call it to-do app. We need to extend the application class. And we need to annotate the to-do app class with @Hilt Android app. Then open our manifest file and type here Android column name equals .to-do app. Then go to our main activity, and we need to annotate the main activity with @Android entry point. Finally, go to our base package, right-click, new, select package, call it DI, that stands for dependency injection, and hit enter. Right-click, and here we need to create our app module. Select new Kotlin file or class, and select object. Call it app module. Our app module needs to be annotated with @module and also with install in. We'll install our module in the singleton component. Singleton component double colon class. What do we need to have in our app module? First, we need to provide our to-do database. Create a function that is called provide to-do database that takes the application as a parameter. And we will need to return a to-do database. Open curly braces. Inside it, we return room database, room.database builder. We need to provide the application, also what kind of database we want to create, to do database class.java, and also we need to provide the name of our database. In order to get the name, we have the name in the to do database. Then we will build it by calling .build. Also, we need to annotate our function with add provides and with add singleton. So we want to provide our repository. So we create a function provide repository. This function will take the database as a parameter. It will return a to-do repository, and we will return to-do repository with the parameter of database.dao, to-do DAO, and annotate the function with add provides and with add singleton. This is what we need for our app. We have successfully implemented dependency injection. Hello, in this lecture we'll start by creating the main screen. Inside our UI package, right click and create a new package and call it main. Inside the main package, create a new package and call it components. In the main package, we will create our main screen, which will be a Kotlin class or file. Select a file and call it main screen. Create a composable with the same name. Then, in the components package, right click, new Kotlin file or class, and call it to do item composable, and select a file. Create a composable function called to do item composable. Our composable will need several parameters. First, the to do item. Then we need a lambda function on to do done that will take a boolean as a parameter and return unit. And also we need another function called onDelete, which will not take any parameters and it will return unit. Inside the curly braces, create a row with a modifier of ViewModel. Our composable will consist of a checkbox with checked is equal to do item dot is done, and on check change will be equal to on to do done. Then below our checkbox we'll add a little bit of spacer with width of 8 dp. Import dp. Then we'll have a text composable with the text equal to do item dot content. And finally add another row with ViewMax width, add a horizontal arrangement dot end. Inside our row, create an icon button. Inside the onClick, we'll call onDelete. Inside our icon button, we'll have an icon that is image vector with icons dot outlined dot delete forever with a content description of delete. This is all for our to-do item composable. Now we need to create a view model. Go to our UI main package, right click new Kotlin file or class, select a class and call it main view model. Our view model will extend view model. Annotate our class with add Hilt view model, and we'll have a constructor that takes a private val repository, which is of type to do repository, and we want to inject our constructor. So annotate it with add inject. Our view model will store the to do items inside a state that contains a list of them. Create a private val underscore to do item state, which initially is equal to mutable state of empty list, which is of type to do item. And expose the property val to do item state, which is of type state, of type list, of type to do item, and it is equal to underscore to do items. Below the state, we'll create several functions. First, a function called insert to do item. It will take a to do item as a parameter. Open curly braces. We'll launch a coroutine in ViewModel scope.launch and call our repository dot insert to do item and provide the to do item. Then below this function, we will create another function called delete to do item. Again, we'll need a parameter of to do item. Open curly braces. Launch a coroutine in ViewModel scope and call repository delete to do item with the provided to do item. Finally, we will need a private function get to do items. We'll call repository dot get to do items on each, and we'll have name the parameter nodes, and underscore to do item state dot value will be equal to nodes, which is a list of to do items, and we'll launch this in ViewModel scope. This function will be called when the view model is initialized. So inside the init block, call the get to do items. Go back to our main screen. We need to provide the view model to our main screen composable. It will be equal to Hilt view model. We'll get the nodes by calling ViewModel dot to do item state dot value. Nodes is of type list of to do item. We'll create a scaffold composable with a floating action button. Open curly braces. Inside the curly braces, we'll call a floating action button with an empty onClick for now. And we'll create an icon with image vector of icons dot field dot add with description of add a new to-do. Inside the scaffold, we'll create a box with a modifier of fill max size. Inside the box, we'll create a lazy column, again with the same modifier of fill max size, open curly braces. We'll create an item that the first item will be a text with the value of my to-dos, colon, and the style will be material theme dot typography dot h6, and let's add some padding. Of 8 dp. Import dp. Then create an if statement. If nodes, we'll check if node is empty. Node is not empty. Open curly braces. And inside it, we'll create a lot of items. Select the one that accepts a list. Here type nodes. Open curly braces and name the parameter a to-do. We'll call a to-do item composable and provide the to-do item to be equal to to-do. Remove these curly braces. On to-do done will be equal to ViewModel dot insert to-do item to-do dot copy, and we'll change is done to be equal to it. This it is a boolean that gets passed from our to-do item composable. Format our code, and then we need to provide on delete. Again, open curly braces, and we'll call ViewModel dot delete to-do item and provide our to-do. If the node is empty, we'll create an else statement, and inside the else statement we'll create an item with text. The text will be equal no to-dos. For you, click on the plus sign to add new to-dos. And we'll add a modifier of padding. For example, 4 dp. Then go to our main activity and remove these example composables in this greeting. Here we'll call our main screen. That's all for this lecture. We'll continue our work on adding a dialog in the next lecture. Let's continue our work from where we left off in the last lecture. We have to implement a way how to add new to-dos. We will begin by creating a dialog in which the user enters their tasks. Inside our UI.main package, create an add to-do dialog. Right-click, new Kotlin file or class, select file, and call it add to-do dialog. Create a composable with the same name. Our composable will have two parameters. The first one will be a lambda function on dismiss, that will return unit. And the second parameter again will be a lambda function called onSave. The lambda will take a to-do item as a parameter, and it will return unit. First, we'll create a box. The box will have several modifiers. The first one will be fill max size. We'll make the box clickable, and if we click the box, we'll call onDismiss. Then add a background. The background will be color dot gray and dot copy, and the alpha we'll copy is 0.6f. Format the code. Inside our box we'll have another box. This time the modifier will be modifier dot clip, and the shape we clip will be rounded corner shape. The corner size will be 8 dp. Inside the box we'll create a column with horizontal alignment equal to center horizontally. Also add a modifier of some padding of 8 dp. Here we'll have a text composable with the text equal to add a new to-do. Below our text we'll have a text field. Go on the top of our function and we'll create the following variable: val text inside the brackets set text should be equal to remember, import remember. It will be equal to mutable state of empty string. The text field value will be equal to text, and the onValue change will be equal to setText. Also, let's change the default colors. So colors will be equal to text field defaults dot text field colors. Remove this thing here, and we'll change the background color to color dot white. Also, let's add a label that will be used as a hint. The label will be a simple text composable with a text of to do. Below our text field we'll have a spacer with a modifier of height, and its height will be 8 dp. Finally, we'll have a very simple button. The on click will be the following: if the text is not blank, we'll call onSave by creating a new to-do item with the content equal to text. And then we'll call on dismiss. But this thing has to be inside the onClick function. Then the button will have a text. It will be a simple text composable with the value of save. Also, we want to make our box clickable, and enabled should be equal to false. Add curly braces, we won't do anything. And also we want to make the background color equal to color.white. And let's add a content alignment inside our first box. The content alignment will be equal to alignment.center. That's all for add to do dialog. Now head to the main view model. Here we'll add a new value, private val underscore is dialog showing. It will be equal to mutable state of false. Initially the dialog won't be showing. Then expose the property val is dialog showing. It is of type state, of type boolean, and it is equal to underscore is dialog showing. Below our init function, we will create a new function called show dialog. This function will set the value of is dialog showing to true. And a second function called hide dialog, and it will set the is dialog showing value to false. That's all for our main view model. It's time to go back to our main screen composable. Here, inside the floating action button on click method, we want to show our dialog. To do this, we call our ViewModel.showDialog. Then, here inside the box below our lazy column, we'll check if ViewModel.isDialogShowing.value. If this is true, we want to show our dialog, add to do dialog. The onDismiss function will be ViewModel.hideDialog. And on save, we'll call ViewModel.InsertToDoItem with the value of it. This it is the value provided with onSave, the one that comes from our add to do dialog. That's all for the app. Let's run and test it. This is the final version of our app. When we don't have any tasks for now, you can see that there are no to-dos for you. Click on the plus sign to add new to-dos. Let's click on our floating action button, and we can see that the dialog is displayed. If we click outside, the dialog is dismissed. Let's click the floating action button once again. Here, let's add a task. Task 1, and click Save. We can see that our task is displayed in the list. And we can click when we've done the task. Let's add another task. And click Save. We can delete our tasks by clicking this icon here. That's all for our to-do app. Thanks for watching.